Our Milky Way galaxy is filled with enormous islands of gas. These great clouds glow from the radiation of super bright stars shining nearby. Astronomers discover the nature of these clouds by studying the colors of light their glowing gas emits. When we spread open the light, each element or molecule in the gas reveals a unique barcode of colored lines. We don't analyze these barcodes as colored lines, however. We plot the strength and width of the lines as a light graph we call a spectrum. These colors come from excited electrons. A nearby star energizes an atom of gas, making its electrons jump into higher orbits. When it relaxes again, the electrons take a quantum leap back down to their normal orbits, spritzing out the excess energy as packets of colored light we call photons. Some gas clouds are dark and cold, and no stars energize them. No electrons are jumping orbits here to make photons for us to see. So how can we learn what dark clouds are made of? Well, not all photons are visible to us. Visible light is just a tiny sliver of a vaster spectrum of many more colors. Beyond the red end of the visible spectrum is the radio spectrum. Radio is a kind of light traveling as a wave too long for our eyes to detect. Clouds that appear dark to our eyes are actually shining in radio light. We build immense radio telescopes to gather these feeble radio waves from these dark islands in space. We graph the wave strength of the radio colors, what we call frequencies, to make a radio spectrum. With radio spectroscopy, we've discovered dozens of complex molecules in these dark clouds and throughout space. Recall, these complex molecules don't emit photons by excited electrons jumping between orbits. Instead, these cold molecules radiate weak radio waves whenever they change their rotation speeds. Each molecule can spin in only a few specific speeds, with no speeds in between. So each speed change results in a specific spectrum spritz or gulp of radio light, and every molecule reveals its own unique spectrum each time it changes its speed. Therefore, even when there are lots of molecules in a vast cloud, we can tell what kind they are by examining the radio spectrum coming from the cloud. Many of the molecules we find are the organic building blocks of life on Earth. We want to know why we're finding them out in space. So astronomers have built powerful radio telescopes capable of detecting fainter and weaker signals. And chemists have built state-of-the-art laboratories that recreate the incredible temperatures and densities in which molecules seem to form in space. They study how molecules grow and transform on the surfaces of tiny dust grains and even in the near vacuum found in molecular clouds. Chemists are sharing these large catalogs of molecular spectra, those fingerprints of molecules, with astronomers to help them identify mysterious molecules found in space. This astrochemistry collaboration may one day uncover the cosmic origins of the complex molecules that make life possible.